It is not recommended to use higher rated breakers, such as the FR34100 or FR36100 on this application for several reasons. Firstly, voltage mismatch is a major concern. The FR34100 is rated for 480 volts, and the FR36100 is rated for 600 volts, while the main service panel operates on a 240 volt system. Using a higher rated breaker on a lower voltage system can lead to several problems. These can include overheating of the breaker components, potential damage to the circuit breaker itself, and a reduced lifespan of the equipment. The breaker's internal components are designed to operate within a specific voltage range, and exceeding this range can cause undue stress and premature failure. Secondly, overcurrent protection is compromised. The FR32100 has a specific trip curve meticulously designed for 240 volt systems. This trip curve ensures that the breaker provides the necessary and appropriate overcurrent protection for the circuits it is intended to safeguard. When a fault occurs, such as a short circuit or an overload, the breaker needs to trip quickly and reliably to prevent damage to the equipment and wiring. Using a higher rated breaker may result in the breaker not tripping fast enough or at all under certain fault conditions. This delayed or absent tripping can leave the circuit vulnerable to excessive current flow, leading to overheating, insulation breakdown, and potentially electrical fires. Thirdly, using a higher rated breaker than required by the system voltage and load constitutes a violation of established electrical codes. These codes, such as the National Electrical Code, or NEC, and the International Electrotechnical Commission, or IC, standards, are in place to ensure the safety and reliability of electrical installations. Violating these codes can result in fines, project delays, and potential liability in the event of an accident or failure. Electrical inspectors are trained to identify and correct code violations, and using the wrong type of breaker is a readily detectable infraction. Fourthly, safety hazards are significantly increased. Oversized breakers, meaning breakers with a higher ampacity rating than the circuit requires, can fail to trip properly in the event of an overload or short circuit. This failure to trip can pose a significant safety hazard, as it allows excessive current to flow through the circuit, potentially causing electrical fires or equipment damage. The purpose of a circuit breaker is to interrupt the flow of current when it exceeds a safe level, thereby protecting the wiring and equipment connected to the circuit. When a breaker is oversized, it may not trip until the current reaches a dangerously high level, by which time significant damage may have already occurred. It is strongly recommended that you use the FR32100 breaker, as it is specifically designed for a 240 volts delta 3-phase 600 amps I-line panel. Using the higher rated breakers is not only unsafe but also violates electrical codes and may void any warranties in the equipment. Electrical equipment is designed and tested to operate within specific parameters, and using components outside of these parameters can compromise their performance and reliability. Moreover, using the wrong type of breaker can void any warranties in the equipment, leaving you financially responsible for any repairs or replacements that may be needed. Therefore, it is essential to adhere to the manufacturer's recommendations and use the correct breaker for the application to ensure safety, compliance, and the longevity of the electrical system. The correct breaker ensures proper overcurrent protection, preventing damage to equipment and reducing the risk of electrical fires. The correct breaker complies with the electrical codes, avoiding potential fines and ensuring the safety of the installation. And the correct breaker maintains equipment warranties, protecting against financial losses in case of failure.